Hi, this is Jack from Maths Forge, and in today's lesson we're going to be doing inverse functions. So the inverse of a function is essentially the opposite of a function. And in today's lesson we're going to learn how to find the inverse of a function algebraically. So let's take a look at our first example. Here we're being asked to find the inverse of f, and this is how you write the inverse. It's f with a -1 on top here. This is not f to the power of -1, so be careful. This is not a power. It's just the way we write the inverse of a function. So find the inverse of f of x when the function f of x is equal to x minus 7 over 14. How is this done? Well, there's a few steps to this. The first step is to replace your f of x in the function with a y. The next step is to swap the positions of y and x. And that looks like this. X is equal to y minus 7 over 14. Notice how all of the other terms stay exactly as they are. We've just swapped the positions for y and x. Now the final step is to rearrange for y. So once you've swapped your y into x, the next step is to rearrange for y. And we do this as follows. So we're going to times both sides by 14 to get rid of that divided by 14 at the bottom. This is going to give us 14x on the left, and on the right it's going to give us y minus 7. And now to get rid of this minus 7, we're going to add 7 to both sides, and this is going to give us the following. It's going to give us 14x plus 7 on the left, which is equal to y. Now, once you have rearranged for y, if done correctly, this is your inverse function of f of x. So we finish by writing the inverse of f of x, so f inverse of x, is equal to what we found to be y, which is 14x plus 7. And if we check our answer, there it is. Now let's do a 2-star example. Here we're being asked to find the inverse of f of x when f of x is equal to the square root of x plus 9 over 5. So step 1, replace your f of x with a y. This is going to give us y is equal to the square root of x plus 9 over 5. The second step is to swap the positions of the x and the y. So we're going to have x is equal to the square root of y plus 9 over 5. And the next step is to rearrange for y. So we have the square root covering everything. So what we're going to do, the opposite of a square root is squaring. So we're going to apply a square to both sides. This is now going to give us x squared on the left, and on the right, squaring a square root cancels it. So this gives us y plus 9 all over 5. Now the next step is to multiply both sides by 5 to get rid of that divided by 5 at the bottom. This is going to leave us with, I'm going to carry on up here, 5x squared on the left, because of course x squared times 5 is 5x squared, and on the right it's going to give us y plus 9. Now the final step to rearrange y is to get rid of this plus 9. So we're going to do that by subtracting 9 from both sides. This is now going to give us 5x squared minus 9, which is equal to y. Now that we've fully rearranged for y, this is our inverse function here. And we finish it off by writing the inverse of f of x is equal to this expression here, 5x squared minus 9. And if you're wondering why we replace f of x with y, it's a very simple reason. It's just to make it easier for us to write out our working out. If you have to write f of x every time for every step of your working out, it gets a bit tiring. So it's easier to write y. Now we're going to do a 3-star example. Again, we're being asked to find the inverse of f when f of x is equal to negative 7x plus 3 all over 8x plus 3. So the same step as before, we're going to replace the f of x with a y, and this is going to give us minus 7x plus 3 all over 8x plus 3. Now the second step is to replace the y and the x's. So we're going to have x is equal to minus 7y plus 3 all over 8y plus 3. And now we have to rearrange for y. Now the first step is to get rid of this 8y plus 3. Since it's dividing into everything, we're going to multiply it onto both sides. So the first step is to multiply 8y plus 3 to both sides. This is now going to give us 8xy plus 3x on the left. Of course, the x distributes into both of the terms. And this is going to equal minus 7y plus 3. The denominator 8y plus 3 gets cancelled out by the times 8y plus 3. Now at this stage, since we're rearranging for y, you're going to want to get everything with a y onto one side of the equation. So I'm going to get this minus 7y to the left-hand side of the equation, and everything that doesn't have a y in it, we're going to get it to the right-hand side of the equation. So to get this minus 7y to the left-hand side, I'm going to have to cancel it out from the right-hand side. So we're going to do plus 7y to both sides of the equation, plus 7y. This is going to give us 8xy plus 3x plus 7y, which is equal to 3. Now the next step is to get rid of this plus 3x, get it to the right-hand side, and we're going to do this by subtracting 3x from both sides. This is now going to give us 8xy plus 7y, which is equal to 3 minus 3x. Now at this stage, in order to isolate the y, because we can't simplify this expression, you're going to need to factorize. And that looks like this. We're going to pull out a y from this expression here, and it's going to leave us with a single bracket, an 8x plus 7. And this is going to equal to 3 minus 3x. Now the final step to get y on its own, since y is being multiplied to this expression here, this bracket, we're going to have to divide both sides by this bracket here, 8x plus 7. So I'm just going to use a different color for this. We're going to do divided by 8x plus 7 on the left-hand side, and on the right-hand side, divided by 8x plus 7. This is now going to give us the following. Y is equal to 3 minus 3x, all divided by 8x plus 7. And now that we have y on its own, this should be our inverse function. So the inverse of f of x is equal to 3 minus 3x, all divided by 8x plus 7. And if we check our answer, there it is. It's written slightly differently, but you do have a minus 3x, a positive 3 on top, and an 8x plus 7 for the denominator. And that's it for the lesson on inverse functions.